Hi folks, so this is question 10. So we're given it's a base in here, but really it's just right angle triangles. So I'll just move across, well we know that there is 10, and then we know that this here is 12, so really we're looking at that triangle, top triangle, and the bottom triangle. So we know that those triangles are similar. So therefore we know that we can compare sides. So we know that 15 over 12, because that's the corresponding side. So that side and that side are corresponding to each other in both triangles. And then we can call this, because we're looking for the side BE, or we're showing that it's 40 anyway. So we're letting that be X. So we know that then if we compare these two sides, so that one and then this one here, so we're going to let that be equal to 10 plus x all over x, and then we have an equation that we can solve. So if you cross multiply, you get 15x is equal to 10 plus x times 12, which is 120x plus 12x is equal to 15x. So move the 12x to the other side, you get 3x, because 15x take away 12x is 3x, is equal to 120. Shouldn't be an x in there actually, it's just 120. Therefore x is equal to 40, so we get x is equal to 40, so we've shown what we needed to show. Right, so the second part asks us for the total internal surface area. So they're cones, so we know it's going to be the pi RL formula. So pi RL, that's the surface area of the curved surface of a that's the curved surface area of a cone. So we're going to be using that. Now the problem here is it's not just an ordinary cone, so it's only going to be the last bottom bit. So what we're going to do is we're going to take the curved surface area of the whole cone, and then we're going to subtract the bit that's missing, the bit down here. So it's like we're looking at a big cone and a small cone, so, and then we're subtracting them. So this is going to be the large one, and then the small one, we're going to find the curved surface area of that, and we're going to subtract them from each other. But that will only find the area on the outside bit, so we need to find the area of the bottom of the basin as well. So this here, but that's just a circle, so we're just going to add on the area of a circle, so plus pi r squared. So that's circle. So then we're just going to sub in numbers, so it will be pi times 15 times 50. So if you look up here, so for the large cone, the radius is obviously 15, and then the height is going to be the 50. Our slant will be 50, because remember x is 40, so 40 and 10 is 50, so just linked, or the length up the side, the slant basically is 50. So that's for the big one. And then for the small one, the small cone, so we're only looking at the small cone now, so this one here, the slant will be 40 for that, and the radius is 12. And then plus, and then pi times, so the radius will be 12, because we want this small circle, so because that's the bottom of the basin. So pi times 12 squared, and we get 1300.6, so it's centimeters squared. That's the surface area then, so the internal surface area. Right, so next part of the question, it's a different type of question. So that's just to draw the net of the diagram. So if you open out the basin, so it'll be something like this. So the bottom part isn't really part of it. So that's just there to kind of help you see the basin part. Right, so if you open it out, it should look like that. So we know that we can put in some things anyway. So we know that that's 10 there. Or yeah, so this part here is 10. Now the top part, that'll actually be the length of the circumference of the circle, because it's the circle when it's the circle opened out pretty much. So the circumference of a circle is found by 2 pi r. So if you do 2 times pi times 15, because the radius of the big circle is 15, so you'll just get 30 pi. You can do that in your head, you don't need a calculator. So 30 pi would be the top part there, and then the other one is the radius is 12, so therefore 2 pi r, so 2 times pi times 12 would be 24 pi. So now that the length here is 24 pi, because that's just the length of the circumference of that circle when it's opened out. So now I can just try and work out this angle as well. So we know that this here is 40 from there to there, and then up there is 10, so therefore the full length is 50. So you can use L is equal to R theta, just from the log tables there. So L would be 30 pi, and then the radius of that circle there, even though it's a sector, it would be 50, and then theta. So 30 pi over 50, so that's just 3 over 4 pi, that's the angle. So 3 pi over 5. So you can put that in there as well, so 3 pi over 5, so that's the angle. So that's all the measurements then. So you don't have to actually construct it with a compass and so on. It's just you have to include all the measurements, so that's everything there. Right, so part B then. So there's a pin code, so it's only got 4 digits, so it's going to have 1, 2, 3, 4. So you're just asked how many different, how many total possible codes are there. So when you put in the first one, you've got 9 different options. So put a 9 in there. So it says no digit can be used more than once, so that's important. So you have to look out for that. So whether it can be used more than once or whether it can't. So in this case, it can't. So therefore, the second one, you've only got 8 options. Then the third one, you've only got 7 options, and then you've only got 6 options for the fourth one. So if it had said that they could be used more than once, you just have 9 times 9 times 9 times 9. But here it's going to be 9 times 8 times 7 times 6, and that's all you have to do. So 3024. That's the final answer. So work out how many of these codes contain the digit 2. Right, so the second one, it's a similar kind of an idea, but it's a little bit trickier. So again, there's 4 different types. So one of them you can only have one possible outcome, because, so we'll just put it there for now. So one of them has to be a 2. So if there's a 2 there, well then there's a 2 gone, so there's only 8 left to choose from, and then 7 for the next one, and 6. So if you multiply those together, it gives you, but then remember that the 2 doesn't necessarily have to be in the first one, it could be in the second one or the third one or the fourth one. So you've got 4 different possibilities for that. So you're going to multiply all of those together, but then you're going to multiply it by 4 because there's 4 different places that it could be. So it's going to be 1344 when you multiply all those. Right, so this one again, this last part, so it's the hardest part. So if I was to take, the first 3 digits need to add to give the 4th digit. So if I was just to take the numbers 1, 2 and 3, so if they were the first digit, they would all add to give me 6. So therefore that's one possibility that could happen. So, but there's different ways of rearranging these 1, 2 and 3 then. So you could have a 3 first and then a 1 and then a 2, or you could have a 2 first and a 1 and a 3, or you could still have a 1 first but then the second one be 3 and the third one be 2. So there's 6 possibilities. It's 3 factorial, so 6 possibilities for just the rearrangements of those numbers. So 6 possibilities. So they all count. So those 6 different possibilities count. So then that's adding to give you 6. Now there's no other way that you could add numbers to give you 6. You only have those anyway, because 4 won't work, because 4, 1 and 1, you're using 1 twice, and 5 and 1, and you don't have another one then. So that's 6 done. So we have to think about 7 then. So to get 7, you could have 1 plus 2 plus 4. So again, you can rearrange them in any way. You could have 1, 4, 2, or you could have 2, 1, 4, 2, 4, 1. So there's 6 again there. So 6 possibilities again there. Now let's think of 8. So to get 8, is there a way that you could add 3 numbers together to get 8? Well, you could have 1, 2 and 5. And then is there any other way? So if you had 1 and 3, yeah, if you had 1, 3 and 4, they would also give you 8. So therefore 1, 3, 4, 8. So then again, for the same reason I used above, there's going to be 6 possibilities for each of those. So we're up to 24 now. And then there's no other ways that you could add 3 numbers that would give you 8 before. So yeah, because if you had 6, then you've only got 1 and 1, but 1 would have to be used twice. So that's 8 done. So then we just have to think about 9. Right, so for 9 you could have 1, 2 and 6. And then you could also have 1, 3 and 1, 3 and 5. They would add to give you 9. And then so 2, 3 and 4 will be the other combination there. They'll also work for 9. And then there aren't any other combination then that will work to suit the condition. Now there's, again, you can rearrange them in different ways. So it'll be 6 for, also just add up all the 6's. So 6, 12, 18, 24, 30, 36, 42. So 42 different ways. That's going to be my final answer. So there's 42 different codes. So that's it then. That's everything for that question and for that paper as well.